All right, today we're looking at fronts. All right, so it's on that page of your purple notes. All right, so let's say on this map of the United States over here, let's say there was a continental polar air mass, a cold air mass sitting right there over New England. And then there was this maritime tropical, this warm, moist air mass right there that moved up and pushed that cold air mass out of the way, all right? When the one air mass moves to the other air mass, they don't like mix into each other. What happens is there's going to be a boundary where those two different air masses meet, where those two different air masses, different characteristics meet. That is what a front is. A front is a boundary or an interface between two air masses with different characteristics, all right? Now we have different types of fronts depending on whether you have cold air moving in warm air or warm air moving in cold air. So we'll look at the various types of fronts and types of weather you get associated with them and how to draw fronts on a weather map. All right, so first off, cold front. All right, so cold front is when I have cold air moving into warm air, all right? Now, cold air is more dense than warm air is. So as a result, cold air is going to kind of hug the ground more. So the shape of a cold front looks something like that. Okay? Now, another thing about a cold front, because it's more dense, it has more mass behind it, more force behind it, it can just plow right through the warm, less dense air very easily. So as a result, cold fronts move very fast. All right? Now, with a cold front, now the warm air is there, this cold air plows into it, some of this warm air is pushed that way, but what also happens is the air right here, some of that gets rammed upward like that as the cold air cuts underneath it. So like right here, there's gonna be air that's rising very quickly. Now whenever air rises, rising air is low pressure. Whenever air rises, it cools down. And when it cools down, you get condensation and you get clouds form. And you end up with these tall, puffy clouds that look like that, right? These are a type of cumulus cloud, right? Cumulus are the puffy looking clouds. Now there's a variety of types of cumulus clouds. There's fair weather cumulus, that's where, you know, it's a blue sky and you see a couple puffy things that look like cotton balls in the sky. The real tall, kind of darker, puffy clouds are a type of cumulus cloud called a cumulonimbus cloud, which is like a storm cumulus cloud. So those are the kind that you, more specifically, the kind of cumulus cloud you get with this. But anyways, so the air rams up, again, makes the clouds, and whenever air rises very quickly, you get storms. So right here, what you're gonna end up with is heavy rain, and thunderstorms quite frequently. Right where that's happening, you also get strong winds. So you get some pretty nasty weather when a cold front passes by. Now, the plus side of it is that with a cold front, you get nasty weather, but it doesn't actually last very long because the only place where the bad weather is happening is right there, right at the front, and the front moves very fast. On average, the typical thunderstorm that you get with a passing cold front, on average, is about 20 minutes. So you get bad weather, but not for a really long amount of time. Now, when the front passes by, all right, and you get exposed to this air back here, well, now you just have the cool air. And remember, cool air is high pressure, the air's sinking. High pressure is clear skies and sunny weather. So after this front passes by, I'm going to have sunny weather with high pressure. So the weather's pretty nice after a cold front passes by. All right, so that's the kind of weather you get with a cold front. All right. A warm front is when I have warm air moving into cold air. All right, so the warm air is going that way, the warm air is going into the cold air. Now, warm air is less dense than cold air is. If it's less dense, it has less mass behind it, less force behind it. It also wants to rise. So when this warm air is moving along like this and it hits the cold air, One, it has a hard time pushing the cold air out of the way because the cold air is more dense. And what happens is it kind of ends up riding on top of the cold air like that. So the shape of a warm front is kind of like that, right? With the warm air rising along the front like that. And again, warm air has a hard time pushing cold air out of the way. As a result, warm fronts move rather slowly. Okay. Now, whenever air rises, you get cloud formation. Like right here, it was rising straight up and it created those clouds right here. Well, here the air is rising, but it's doing so at an angle and it's doing so more slowly, but it's still rising. So you're going to get cloud formation. The first type of clouds that you see with a warm front are these kind of thin, wispy looking clouds, kind of look like little feathers. We call those cirrus clouds. All right. So they're really high up. Again, they look like little white feathers up there. The weather conditions are usually still pretty good at that point. But what's going to happen over the next several hours as the warm front's moving towards you is what you'll notice is the sky is gradually going to become thicker with clouds. And what else is going to happen is the clouds will get thicker and they'll get lower in elevation. All right? You get to a point where the sky is just kind of covered with a gray sheet of clouds. When it looks like there's a gray sheet of, over the sky, those kind of clouds are called stratus clouds. All right, so the gray sheet of clouds is called stratus cloud. Now, as far as precipitation goes, again, whenever air rises, you get clouds forming and you're going to get rain. But because the air is rising very slowly and the cloud development is very slow, what you'll end up with is like over here, I might get some sprinkles, and then like a little light drizzle, and then like a light rain over here. So gradually, the amount of rain is going to gradually get a little bit heavier. But it's never going to be like a super downpour like you have up here, with a thunderstorm, you get, big giant drops of water. Here, you're not going to get that. It's going to go from like a sprinkles to a drizzle to a light rain usually. Now, because the front's moving slowly, this rain lasts for a long time. Okay. Now, if you look at where it's raining, with a cold front, here's the front right there, it rains right at the front. With a warm front, the actual front's back here. So where it's going to be raining is it rains ahead of the front. So it's going to be raining before you actually get to the warm temperatures. Right? So with the warm front, it rains ahead of the front. Now, warm fronts move a lot more slowly than cold fronts do. As a result, if you see these cirrus, if you're out in a lake or something like that in a boat and you see these cirrus clouds right there, there's really no need to get off the water right away. On average, the amount of time it takes to go from when you see the cirrus clouds to when it starts raining, on average, is about 18 hours. So if you just see the cirrus clouds, you're good for another several hours at least before it starts raining. Whereas with a cold front, if I'm out in the lake in a boat in a cold front and I see these guys coming at me, I better get off the lake really quickly because this moves really fast and is associated with violent weather. All right, so that's the warm front. After the warm front passes by, I get the warm conditions from back here. All right. So these are the two, warm fronts and cold fronts, are the type of fronts you're going to see most frequently on tests and quizzes and labs and stuff like that. There are a couple other types of fronts too. Stationary front. All right. So let's say I have a mass of cold air right there. I have a mass of warm air right there. All right. Now, if the cold air was moving into the warm air, it'd be a cold front. If the warm air was moving into the cold air, it'd be a warm front. But what if they're just kind of not moving into each other at all? They're just kind of like sitting there, right? Well, the boundary between them would still be considered a front, but you don't get a lot of action there. So you can get a stationary front either with the two air masses just kind of sitting there, or if the two air masses are moving, but they're moving parallel to each other like that, the boundary between them would be a stationary front. All right. The other type of front is an occluded front. What occluded fronts are basically when a cold front passes a warm front. So what you have is like, let's say you have cold air over here, warm air right there, and cold air right there, right? The warm air is moving that way. Warm air going into cold air is a warm front. And if this cold air is moving that way, cold air going into warm air is a cold front, right? So this whole thing's moving that way, all right? But the thing is, cold fronts move faster than warm fronts do. So this whole thing's moving this way, this front right there is eventually going to catch up to that front right there. So when it catches up to it, what happens is these two cold air masses combine, and I end up with something basically like this. All right, so this part of the cold front right here scoots underneath that warm air and combines with that mass of cold air right there. And then this big wedge of warm air gets forced upwards. So I have this big giant mass of warm air gets forced upwards when the cold air cuts underneath it. So I have this big giant section of warm air going up. So again, whenever air rises, you're going to get rain, and this is like a big chunk of air rising, so you're going to get lots of rain. So occluded fronts result in very heavy rainfall to them. So this would be like an all-day heavy rain. Like a warm front might be like an all-day light rain. This would be like an all-day heavy rain right there. All right, now weather systems, including fronts, don't just move randomly across the country. They follow set patterns, and that's what this map shows you right here. This shows you the direction that weather systems, including fronts, typically move across the country. So where they typically go is they typically trend up towards the northeast. And the reason why the weather does that is because of the prevailing winds make the wind do that. But weather typically moves towards the northeast across the country. All right, now, there are symbols for these on a weather map, and those symbols are in your reference tables. So on page 13 of your reference tables, where we've had this other weather stuff, there's a section here with fronts, and it shows you the symbols that are used on weather maps to show the fronts. So cold fronts are going to be represented by a line with a bunch of little triangles on it. Easy way to remember that, just think about like a line with a bunch of little icicles on it. If the map's in color, this is typically blue as well. The symbol for a warm front is a line with a bunch of little half circles on it. Easy way to remember that is just imagine a bunch of little rising suns, so it'd be warm. Right? And if it's on a colored map, this would be red. Stationary fronts are a combination of those two. It's got the blue triangles on one side and the red circles, half circles on the other side. They kind of tell you what side's the warm side and what side's the cold side. So like right here, this would be the cold side and that would be the warm side. Occluded front, because it's where a cold front passes a warm front, it's got both symbols on it, but since both fronts are moving the same direction, both symbols are on the same side. But still be alternating colors, blue, triangle, red half circle, blue triangle, red half circle if it was a colors map. All right. So you don't need to memorize these things because they're in your reference tables, but again, it's easy to remember triangles, icicles cold, half suns warm. Right. Now, how you go about drawing these on a weather map is actually pretty easy. You only need to know 2 pieces of information to do so. So we'll look at how to do that. All right, so to draw a front on a weather map, the only weather data you need is the temperatures and the wind directions. So what I have up here is a bunch of station models, and the only information I put in those station models is the air temperature and what direction the wind's coming from. So remember, on the station model, the little shaft points the direction the wind's coming from. All right, so for this guy right here, that means the air's coming from that way, blowing that way. All right. So how do I go about drawing a front? All right, so first off, remember what a front is. A front's a boundary between two air masses with different characteristics. So my first step is I want to draw a line separating the warmer air from the cooler air. So I look on here, here's a bunch of temperatures in the 50s right there. Here I got a bunch of temperatures in the 30s right there. So I want to draw a line separating the 30s from the 50s, the warmer air from the cooler air. So here, that would be the location of my front. All right. Cold air on one side, warm air on the other side. Next, I got to figure out what kind of front that is. All right, so the little shafts are pointing that way. That means the air is coming from this way, going that way. So the 30s are going into the 50s. So the colder air is going into the warmer air. So that's just what I have right here. Cold air going into warmer air, so it's a cold front. Now back here, we said the symbol for a cold front is little triangles. So I have to put the little triangles on that line. And how I know what side of the line to put the triangles on is based on what direction the front's moving. So if the air's coming from this way going that way, that means the front's going that way. So the little triangles are going to be like little arrows pointing the direction the front is going. So the side I would put them on is this. Is right there. All right. All right. So there is a cold front, and the front's moving that way. So if I was located right there on the weather map, there's a good chance I'd be experiencing thunderstorms. All right. All right, let's do another one. All right, so I have my station models with the temperature and the wind direction. Again, my first step is I'm going to draw a line separating the warmer air from the cooler air. So here's a bunch of temperatures in the 50s, a bunch of temperatures in the 70s. So I'm going to draw a line separating the warmer air from the cooler air. So there's my front. Now the little shafts are pointing this way. That means the air is coming from this way, going that way. So I have 70s going into 50s, so warmer air going into colder air. So that's what I have right here, warm air going into cold air. So it's a warm front. The symbol for a warm front is a little half circles. So I'm going to put the little half circles on that line. Now, since the front is moving that way, I'm going to put the symbols on that side of the line. So it would be that would be the symbol for the warm front right there. All right. So if the warm front's right there, there's the warm front right there. It usually rains ahead of the warm front. So if there's the front right there, it's probably raining like over there someplace. All right. Anyway, so that's how you draw weather fronts on a map.